In the previous two lessons, we've talked about writing the equation of a line if you're given the slope and you're given the y-intercept. And pretty much if that's the situation that you have, you would plug in whatever number you had for slope in for the m and whatever number you have for the y-intercept in for the b, and you have your equation of the line. In the last lesson, we did, well, what if you're given the slope and a point that's not the y-intercept? And if that's the case, you use the point that you're given, which is not the y-intercept, and you plug those numbers in for the x and the y along with the slope, and you find the y-intercept. So now we're going to look at what if you are just given 2 points. And I want to begin with going back to the graph and really establishing that this is something that we can do. So I'm going to go ahead and put our coordinate plane on the slide here. And we'll look at the problem. Write the equation of a line that goes through the points 1, 6, and 3, -4. Okay? And so let's take a look at this. We have the point 1, 6, which means I go over 1 and up 1, 2, 3, 4, 5, 6. So right about there. And the point 3, -4. So 1, 2. Now, before I plot that, notice that there's an infinite number of lines that go through this point, and we talked about that in the last class, the last lesson, where there's an infinite number of lines that go through that point. Now, to figure out which line we want, we can use the other point. So we go over 3, 1, 2, 3, and down 1, 2, 3, 4. So right there. And there is only one line. Now, when you're watching these videos, if you are a student in Algebra 1, you probably haven't taken geometry yet, and so you're probably not familiar with the idea that 2 points determine a line. But you can kind of see it here, and if you're watching this video as a review, then that might be an idea that you have encountered before. But once I have that second point, I go from infinite number of lines to just one. There is only one line that will go through both of those points, and I can go ahead and draw that line. That was a terrible job drawing it, but you get the idea. So just by doing this, first of all, we know that if there is only one line and I have information about it, I should be able to come up with the equation, which is why this is a doable task. So if you have the 2 points, there is only one line. If there's only one line, we should be able to find the slope and the y-intercept. A couple of other things that you can determine just by doing this. We know that it has a negative slope. And the reason we know that is because it tilts down from left to right. So whatever it is that I end up doing, I end up with a positive slope, I know I've done something wrong. We also know something about that y-intercept. Now, on mine, it looks like it's at maybe 8, but keep in mind that my line is terrible, okay? I didn't even get that point. But there's a couple things that I feel pretty confident, concluding. So this point right here is at y = 6, and I know the line has negative slope. So whatever the y-intercept is, b is greater than 6. Okay? Because here's where the 6 is, and I know the line has to go up a little bit from there in order to get to the y-axis. So if I end up with a y-intercept of 3, I know I've done something wrong. If I end up with a y-intercept that's negative, I also have a pretty good idea that if I get a y-intercept of 40, that is also wrong. It looks like it's an 8. It could be a 7, an 8, a 9, maybe a 10. We haven't done the problem out yet, but if I end up with 40 or 100, that's wrong. It's not that far away. So if you're taking a test or you're being assessed on something like this, like write the equation of line, plot the points and see what you can tell about the line just from plotting the points. Sometimes, if you're really good, you can actually get the slope, by counting the rise over the run. And then you could actually, if your graph is really well done, you might be able to see the y-intercept on there. You might actually be able to see it. And if it's a multiple choice test or something, you might be able to pick the right answer choice, even if your graph isn't that great, as long as you understand things like this. Like, this is where I can plot the points. This is what I know. And a lot of the tests that you guys take are multiple choice tests. So let's go and talk about how we actually can do this. So to write the equation of a line, we need to know the slope and we need to know the y-intercept. And if you've been following with these lessons, or you've been paying attention in your own math classes, you should know that, like, if we can find the slope, we can find the y-intercept, we've got this. I'm given 2 points. If I'm given 2 points, there is a way to find the slope. And even if you weren't sure if that's the direction that you should go in, if you're given 2 points and you don't know what to do, go ahead and find the slope. It's better than leaving something blank. And that's coming from having recently graded some tests where people just like knew how to find the slope but didn't bother to try to do it. So, all right, so let's go and find the slope here. So the slope, and I'm going to keep writing that formula down just for that emphasis, especially in an Algebra 1 class. And we'll pick like x1, y1, and x2, y2 over there on the right-hand side. Y2 is -4, y1 is 6, x2 is 3, and x1 is 1, and so that is -10 over 2, which is -5. Okay, so that looks pretty good. Slope is -5, and that confirms what we knew here, negative slope. And now the problem kicks right back to what we were doing in the last lesson. If you know the slope and you know a point, you can go figure out what the y-intercept is. Except where in the last problem, last lesson, we only had 1 point to pick from. Now I actually have a choice of 2. I can pick either of those points. Either one of them is going to work. I like this one because both of the numbers are positive and I don't really want to use negatives if I don't have to. So we have y equals mx plus b. I'm going to go ahead and use 6 for my y. -5 is my slope. And I'm going to use 1 for my x. And then -5 times 1 is -5. Add 5 to both sides, and I get 11 is equal to b. And I'm not done, because what I'm trying to do is write the equation, but now I have the slope and now I have the y-intercept. So let's go ahead and write that equation. Y is equal to -5x plus 11. And there we go. And that also confirms what we have here. B is greater than 6. Now, it looked like 8. I went up to about 10 because I hadn't done it. 11's a little bit higher than I thought it was going to be. I didn't really think my line was bent that much, but it's not so high that I'm like, ooh, there's no way it could be 11. Like, yes, it could be 11. Now, just to illustrate that you can pick either point, okay? I'm going to do a quick rework of that, picking the other point. I just want to do this one time to illustrate that it doesn't matter which point you pick. So we'll pick the 3 and the -4. So -4 is equal to -5 times 3 plus b. -5 times 3 is -15, and we'll add 15 to both sides. -4 plus 15 is 11, and of course that confirms what we already knew. Just notice that the arithmetic was a little bit messier on this one. We had bigger numbers, and we also had more negatives to deal with in there, and we just kind of like to avoid that if we can. So there we go. That's pretty much the process. And graphing the points, seeing what they look like, that is an option that you have. It's always just one of those tools in your toolbox for how you can approach a problem, to visualize it, to get your head around it, and but it's not required. Like the directions say write the equation of a line, so that's what you need to come up with. How you come up with it, just always follow the directions. All right, let's take a look at another one. We'll do -3, 2, and 5, -2. And I'm going to go ahead and continue graphing it because I think too many of my own students really don't connect the ideas and don't know how to leverage maybe a part of the math that you're good at to help you with the part that you're maybe not as good at, so that you can see different ways of approaching the same problem. So -3, 2 is right here. and then 5, negative 2, 1, 2, 3, 4, 5, negative 2 right here. Okay, and so here we go. Okay, and so a couple things I know about this line. I know that it has negative slope. So when I do my slope calculation, and it looks like the y-intercept, B is between, you know, we got to account for the fact that it's a little bit wobbly, but it looks like it's positive. It might even be like near the 1. I'm going to go and say it's like probably between like -3 and +5. Okay. And I'll just cushion that with like a question mark because we're really estimating. And, you know, the last graph, I was kind of off by a little bit. So now you could get the slope again from counting your rise over your run. So you could just do this. You could go, you know, down 1, 2, 3, 4 and over 1, 2, 3 over 8. So rise over run, we went down 4 and over 8. Simplify that fraction to -1/2. Okay. So you can get it that way. Like you just, you know, a student really, really understands the math and understands, you know, how these things are related, how these formulas are related, is able to approach a problem from different ways. And it can really, really help you when you get, like, if you have test anxiety, to be able to pull like another little trick, you know, out. So, all right, let's go ahead and do the calculation out. So again, I'm copying that formula, not because I need to copy that formula. Great. My wrist touches a little button to advance the slide there. But because it's good, it's just good form. So we'll just do x1, y1, and x2, y2. And let's go ahead and plug that in. So we have -2 minus 2 over 5 minus -3. So, you know, if you need to go back and rewatch the video on slope to sort of reinforce this, but you got -2 minus 2. Don't think 0. Think, okay, -2. You know, if it helps to do this, -2 plus -2 gives us the -4. And then remember what's happening here. Subtraction means to add the opposite, and the opposite, so that's really 5 plus 3, -4 over 8, which is -1/2. You're like, but Miss Taylor, like you could have, you already had that. True. And in a problem like this, you can get it off of the graph like that, but not every problem will you be able to do that. So you still want to make sure that you know how to use the formula. We'll look at a word problem next that's going to have like some numbers on it that you wouldn't want to get it from the graph. Now we need to find the y-intercept. And so I've got some of my numbers. I know I'm going to use -1/2 for my slope. So I'm writing right here. I don't like either of these. Okay, well, all right, so yikes. Both of them have negatives in them. I'm going to go with this point, reason being that the numbers are a little bit smaller. If I can't avoid the negatives, you know, it is what it is. So we'll use y is equal to 2. We'll use x is equal to -3. And then we'll have a little bit of scratch work over here. -1/2 times -3. Remember, that's -3 over 1. -1 times -3 is +3 over +2. And now we need to subtract that from both sides. And just in case anybody's thrown by this, I went from a horizontal fraction bar to a slashed one. They're the same symbol. The only reason I converted over to like the kind of slash looking symbol is because I was running out of space on the bottom of the screen. So those are exactly the same thing. Let's keep doing like our scratch work. So we have 2 minus 3/2. Now subtracting fractions is just not as much fun as multiplying. Multiplying, you just go straight across. Subtracting, you actually do need a common denominator. And so what I want to do is write the 2 as a fraction, but I want to write it with a denominator of 2. And I can do that if I write it as 4 over 2. Just give yourself a chance to think that through, like 4 over 2. Is that the same as 2? Yes. And then 4 minus 3 is just 1. And so b is equal to 1/2. And then, of course, we need to write the final equation. So y is equal to negative 1/2 x plus 1/2. Okay, and then this hot mess over here, this is just scratch work. You kind of want to keep this kind of work away from your algebra. This is like arithmetic scratch work that you would do off to the side. You guys are past the point where a teacher's going to grade you on the mechanics of how you're adding your fractions together. You just don't need to show it. Now, before we leave this, we know we got the negative 1/2. Does a y-intercept of 1/2 appear reasonable based off of my graph? Yes, absolutely. It actually looks a lot better than the graph that I did before. It does not exactly at the 1/2, but that's like really, really close. And that can give you some confidence if you tend to not have a lot of confidence in your answers. If you can just plot those points and draw that line, you'll feel a lot better about your work. And you might even catch a mistake while you're at it. Now, this particular skill, this is actually being able to write the equation of a line given 2 points, is one of the most useful things that you will ever do in math. And it has a lot of applications to a lot of different things. And I know we're not really emphasizing a lot of the applications in this video series. This is really about the mechanics of being able to carry out the calculations. But there is a pretty good word problem example that we'll take a look at on the next slide. Okay, so this is long before anybody probably watching these videos was born. I remember 1986 and 1992, but I think most of my students at this point were born in the mid-2000s at the time that I'm recording this. And so this is like ancient history. But numbers are numbers. If you'd like to put in different years, you can make this work. But we have a store at a shopping mall sold 4,180 pairs of designer jeans in 1986 and 5,710 pairs in 1992. And I didn't take a picture of the actual problem here, but it says write an equation that gives the number y of pairs of designer jeans sold in the store shown in terms of the year x. Let x equals 0 correspond to the year 1980. So let me write that down so that you can actually see it. Okay, so what we're going to do here is write an equation that models the relationship, and this might make it a little bit more practical for you, that models the relationship of the number of jeans sold as it depends on time. So right now you can tell that the number of pairs of jeans, like it's going up. What we would like to do is quantify that a little bit more and get a sense of like, well, how fast is this happening? And then, what you would do in real life is you would actually look at more than just the 2 data points and you would determine whether or not this relationship was linear. But that kind of gets into a little bit more of what you could do with the numbers. But somebody might want to know, like, how many pairs of jeans do we need to order? Like, can we afford that? Is demand increasing, decreasing? Because stores will make decisions, like real life practical decisions based off of trends like this. Now, something that you might be unfamiliar with is the let x equals 0 be 1980. You don't have to do that. It's actually going to work out the same way even if you don't do it that way. But you can, what they're trying to do there is they're trying to shrink the numbers down so that you're not dealing with really, really big numbers. So if 0 is 1980, then 1986 would be x is equal to 6. And what they're doing is they're just kind of restarting the years. And then 1992 would be the year 12. Okay, all they're trying to do there is to give you smaller numbers to work with instead of numbers in the thousands. But it works either way. So let's go ahead and see. Now, this, notice, I've still got the coordinate plane up here. We don't really want to graph this. These numbers are way too big, and we definitely don't want to count the slope, okay, because it's just too big. And if you're thinking, well, I think I could figure it out by like counting, but like probably what you're thinking is you would use the formula. So let's go ahead and I'm going to put the points up there. So they told us that X was the time. Okay, so we have the year 1986. And the number of jeans that goes with that is 4,180. And then the other year was 1992, when I was in middle school. And the number of pairs of genes was 5,710. And so we want to write the equation for that line. So let's go ahead and write our slope formula down. And remember, math is consistent, so it doesn't matter if those numbers get big, okay? Like they're the same numbers. And then we'll do x1, y1, and x2, y2. And then I'll show you about the 0 and the 1980 equals 0. All right, so we have 5,710 minus 4,180 over 1992 minus 1986. And then my numerator there is 1530, and I don't know if you can tell, but I paused the video so I could do that out. And then 1992 minus 1986 is 6, and then that is 255. Now, what that tells you is that, like, over the course of 6 years, the number of genes that were sold went up by 1,530, or 255 additional pairs per year. That's your slope, and it actually represents a rate of change. It's how many more pairs of genes they sold on average each year. Now we need that Y-intercept, and we can pick either of those points. So we can go ahead and we'll do, I don't think it matters, but we'll do the 4,180 equals 255 times something. 1986 plus B, and we can like solve it from there. They're actually going to come up with like a this is where the 1986 is awful. It doesn't affect the slope calculation at all, but it's going to cause this number to be like huge, which probably means it's a good place to stop with that. So what they wanted you to do was to alter this X value and just kind of reset it back to a smaller value. So instead of 1986, you would use a 6 there. And instead of 1992, you're rebooting to a 12. So when you come over here, you'd end up with 12 minus 6, which is still going to give you the 6. So it doesn't affect the slope at all. Right here is where it ends up being much, much, much nicer. So I would much rather use a 6 there than whatever that was, 1986. This we actually already know. We're actually going backwards here. So 255 times 6 is the 1530. And then subtracting 1530 from both sides, we end up with 2,650. And so the equation that would model this is y is equal to 255x plus 2,650. And if you want to interpret this, what this means is in the year 1980, okay, when x is 0, so in the year 1980, 2,650 pairs of genes would have been sold that year. So it kind of allows you to go back in time. It also allows you to go forward in time so that you can predict how many pairs of genes. Now, of course, like real life, it's so much more complicated than that because there is a saturation point where you're not going to sell any more genes. But I think it is a really good example of where this can be applied and what you can do with it. So we're running really short on time, so I'm not going to spend a lot of time explaining the practice problems. I'm just going to put them up there so that you can pause them and we can use the remaining time in the session to go over them. Okay, so just 6 practice problems. Write the equation of the line containing -1, -1, and 2, 8, 1, 2, and 4, -1, 2, 0, and -4, -3, 3, 1, and -3, 5, 1, 3, and 3, 3. And then for number 6, I want you to try to do it with the graph only and not using the algebra to back you up on that, on the equations. So pause the video, work those problems out, and then unpause to check your work. Okay, First one, your final answer should be y equals 3x plus 2. As always, pause on this slide. Take a look at what I did, especially if you got a different answer. You want to find out. If you think that I did something wrong, you can always mention it in the comments. But, you know, again, your work might not look identical to mine, but you should still get a slope of 3. You might have picked a different point, but you should have still gotten a y-intercept of 2. And so we should land in the same spot. It is highly unlikely that you and I would pick all the same decisions all the way through all of the problems, maybe a couple problems. Next one, the final answer should be y equals negative 1x plus 3, or you don't have to use the 1. You could just say y equals negative x plus 3. Either of those are correct. Your slope should be negative 1, and you should get a y-intercept of 3, plugging in whichever point you decided to plug in. Pause on this slide if you need to copy down my work or you need to look at it more closely and compare it with what you have. Next one, now we start getting some slopes that are fractions. So the way I pulled these out, I ended up with negative 3 over negative 6, but a negative divided by a negative is a positive. So we end up with positive 1/2. I picked the problem with the 0 because I will pick a 0 every single time that I'm allowed to pick a 0 for something. And so we end up with like 0 equals 1 plus b. Again, you know, if you need to slow it down and review that multiplication there, you know, do what you need to do to be able to understand it. The y-intercept is negative 1, so you should have y equals 1/2 x minus 1 as your final answer. Very unlikely that you would get the right answer with a mistake in there, but it can happen. You can like make 2 mistakes that kind of cancel each other out. It doesn't happen a lot, but I have seen it happen. Next one, we have an even better slope. So I got 4 over negative 6. Now, I'm just not a huge fan of putting the negative in the denominator. There's nothing algebraically wrong with it. I just don't like it. And so I move the negative up into the numerator. It's the equivalent of picking 0.1 and 0.2 differently. And then 4/6 simplifies to 2/3. I went with the ordered pair that had both positives. So I could avoid additional negatives there. Here the 3's cancel out, giving you a negative 2, and you should get a y-intercept of 3. So y equals negative 2/3 x plus 3 should be your final answer. Next one. I love zeros. We had 0 divided by 2. If you're not sure if you remembered what that is, go throw it into your calculator. We do have a slope of 0, which if you remember back several lessons now is a horizontal line, but good to bring it back up. I went through the algebra, but once you like know that it's horizontal, you can probably get it from here, that the y value is always 3. But you can grind out the algebra on that as well, and you end up with a y-intercept of 3, and then you plug it back in, and 0 times x is 0, so it actually drops out. And so that's why you have that equation of a horizontal line there. And the last one, this one I had to tweak a little bit. So this one I wanted you to try to do it with the graph. So I plotted the 2 points. Those are the 2 purple ones. And then when I went to connect them, if you look closely, like I really did not do a great job. I am quite a ways off from the actual location of that. It did not affect my slope calculation. So I counted like up 3 over 6 to get rise over run and get the 1/2. But then I realized that this was an issue in getting that y-intercept. So what you see in the gray is once I knew that the slope was 1/2, I actually counted like up and over. So I went up 1 over 2. And you can see how my sketch of the line is off from where it should have been. Up 1 over 2, up 1 over 2. And one of those points, like I landed on the 5 for the y-intercept, which of course is a little bit below where I drew the line. So the y-intercept is 5, so we get y equals 1/2 x plus 5 for that one. And I actually like that I kind of had an issue with that because it shows, the advantages of graphing, which is it gives you that picture and a visual way to see the relationship. And one of the disadvantages of graphing is that it is highly, highly vulnerable to inaccuracies, which can cause some problems with some, issues with some problems that we'll do in the future. And we have some ways around it. So that concludes this lesson on writing the equation of a line given 2 points. And I'll see you in the next lesson, which I believe is standard form for the equation of a line.